So section 3.3, and we're going to split this between 2 days, so we can call it 3.3a, and we're just going to look at those different properties of logarithms. So properties of logarithms, right? And there's 3 properties that we're going to talk about. We're going to talk about the product rule, the quotient rule, and the power rule. But before we get going on those little properties, I want to talk about natural log and what natural log means, and how to kind of work on some of those problems. So when it comes to these rules, regardless if it's log or if it's written as natural log, so sometimes you get the log, L-O-G, and I make my L's in cursive just because if I don't, sometimes it's like, what's 10G? 10 grams of what? Right? So you don't have to, but I think it's sometimes easier up here on the screen. And the other thing we're talking about is these natural logs. So it's Ln. It's not 1n, it's Ln, right? So I just do mine in cursive. Okay. What do these two, how are these two related? So when it comes to the natural log, that ln of x, all that is we're writing log base e of x. Instead of writing that log base e, we just like to write ln. I don't know, maybe mathematicians are a little lazy or something. Maybe that's why we like to do it. I know I have a highlighter on here. Let's see if the highlighter shows up. Probably not. Oh, that's not thick enough. Right. So that ln and that natural log of e, those are the exact same thing. That's the only thing that's different in that problem. So anytime you see natural log, and it's written this way, if it makes you warm and fuzzy, you rewrite it like this. If we see log base e, we just know that if we want to make a little shortcut, we can just write it as natural log. So it means the exact same thing. It's just another way of writing it. We do the same thing when it comes to log base 10. If we had, oh, that's really bad. If we had log base 10 of, I don't know, let's say 5, right? Sometimes instead of writing that with the base of 10, since we are in a base 10 system, that's how we count, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then at that 10, we moved over a whole unit. Sometimes we write it as log base 5. So, oh boy. So sometimes that 10, if there's not a number there for that base, that little subscript, we automatically know that it's going to be a base 10 system because that's what we count it. So usually they never write that 10 in there. So if you see it without the base written in there, it's not that there isn't a base, there has to be a base, and that base would be 10. Okay? So let's talk about our little natural logs for a real quick hot minute. So let's say I had the natural log of, let's say, e to the 6th. Right? So if I want to write this as a logarithm, I know that my natural log is the same thing. Man, these colors. That natural log is the same thing as log with a base of what? Exactly, a base base e, right?
Oh.
Right? And that's always going to equal our exponent, and our exponent is 6. So if we taking that middle part out, right? So we know then that the natural log of e to the 6th, we can always simplify that down to 6. Or if I had the natural log of e to the, you guys like the number 7, right? I know that that's going to equal 7, right? So just keep that in the back of your mind when we go through some of these problems. All right, so let's get on with the rules. We're a rule following team today. So the first rule we're going to talk about is the product rule. And in mathematics, when we see the word product, product is like the same thing as multiplication, right? So the rule, if they give us the log of some base and they multiply two numbers together, let's say just m times n, to make it where it's a more user-friendly type of problem where we can kind of do some math here in a couple days on it, we can actually separate this. And it's going to separate into log base b, we have to leave our base, m plus log base b of n. So when we have the product property, we are going to be adding those two logs together. So if we actually think about exponents, if we had, you know, x to the 6th times x to the 7th, when it comes to the product property, when it comes to exponents, and we're multiplying, what do we do to the exponents? We add them, right? So that's going to give us x to the 13th if we simplified it all the way out. So the same thing follows through when it comes to our logarithms. If we are multiplying them, we can separate it by adding. Okay? So let's try an example or two. So let's go with, oh, well, here, I'll write this on there. And this works the same with like natural logs. So if we had the natural log of m times n, that's just going to be the natural log of m plus the natural log of n, which is log base e, right? If you want to write it out that way, you could even write it out that way. And then in a few days, we're going to get to where we're going to actually do some mathematics with those. So today is really just a matter of making sure we can get this into this form, or really technically going in the reverse direction, going this way. So that way, when we get to doing some computations, we know the process that we have to go through. All right, so let's try, let's say we have log base 4 of 7 times 5. Granted, I understand that that's log base 4 of 35, but we're just using this as an example so we just know how this property or how this rule works. So since I'm multiplying, I can separate this into two separate logs with addition, right? So I can have log base 4 of 7 plus log base 4 of 5. So make sure you're always including your bases, right? And then since this was product, we got the plus going on. Fancying it up a little bit, we can look at some natural logs. So what if I had the natural log of, that's natural log of e to the 5th times 3. So same principle applies. This would be the natural log of e to the 5th plus the natural log of 3. And then we could get really fancy because we just learned that if we take the natural log of e, it's always going to be whatever that exponent is, right? So we could technically simplify this guy down. If you needed to, you could write it out, right? So the natural, so that would be log base e, right, of what number? E equals your exponent. What's your exponent? 5. So we can simplify this guy down to 5, and then we have plus natural log of 3. Or if you wanted to, and I'm good with that answer, right? That's beautiful right there. If you wanted to write it as a log instead of a natural log, you would have 5 plus, what's natural log stand for? Log base e of what number? 3. And as far as we can go because we don't have an exponent, right? So they really kind of want you guys to keep it in this form just because it's in the natural log, so they want you to give your answer in a natural log. But if you wrote it as this, I am fine with that as well. Right? Helps you at least get in the habit of remembering and retaining the fact that natural log is the same thing as log base e. Sound good? Well, since we did the product rule, we might as well do the quotient rule. And in mathematics, quotient means divide. So this would be, let's say we had the log, a sum base b of m divided by n. So if we think of exponents, when we have exponents and we're dividing an exponent over an x, or x to the 7th over x to the 3rd, we know that we subtract our exponents. So the same thing happens with logs. So we'd have log base b of m minus log base b of n. Same thing, same rule applies if we have natural log. Okay? So we just have natural log of m minus the natural log of n. Right? Try a couple examples on these. So let's say we have log base 7 of 19 over x. So I get my log, I get my base 7, so that's got to stay the same through my whole problem. I got a quotient, or I'm dividing, and if I'm dividing, I know that I am subtracting my two logs. So I'm going to get what? Log base 7 of 19 minus log base 7 of x. And for today's lesson, that's as far as we need to go. Right? A couple days from now, we'll get to where we actually work on these problems and see if we can simplify them even farther. Sound good? And then throw a couple more in here. What if we had the natural log of e to the 3rd over 7? Well, I know that I'm dividing using the quotient rule. I'm going to divide these guys. So I'm going to get the natural log of e to the 3rd minus the natural log of 7. So then, if we wanted to, our natural log of e to the 3, we know that that's going to simplify down to 3 minus the natural log of 7. And then we are good to go. So the last one we have is the power rule. So the power rule. So power rule is what we're talking about when we're looking at exponents. Exponents, powers are kind of the same principle. So let's say we had log of some base b of m, and it's raised to the degree or the power of p. We know that in order to make this a little bit more manageable for us to work with, a simpler form, our p can come out to the front. So this would be the same thing as p times log base b of m. So let's say we had log base 5 of 7 raised to the 4th power. So to make this a little bit more user-friendly for us, we can use that power rule, and we can take our 4 and we can pull the 4 out to the front. So this would be 4 times log base 5 of 7. throwing out a fancy problem, we could have the natural log of the square root of x, right? So we need to be able to write our square root as a power, and that would be natural log of x raised to the 1/2. And then now using the power rule, we can pull the 1/2 out to the front and get 1/2 natural log of x. So when you're working on these problems, ultimately your goal is, they're not linear, but you know how this guy has got the little exponent up there? You want it in that like nice little straight line. You might have a number out front, you got a base, and then you have that number, right? You could have a number out front, this is log base e, right? And then you have that number. So same thing on like these ones. You don't want the division in there, right? You want it to be kind of nice and linear, right? To where you have your log, you got your base, and you got a number. You got a log, a base, and a number, right? On this one, right, because you would have had a log and a number, right? We're not looking for like log, base, number, and a number. We want log, base, number, log, base, number. Granted, you could have a number out front by using that power property, but I hope you get what I mean, like when you just want these types of problems in your answers, unless you're going the opposite way. And then we can go the opposite way too. We can combine these because we know that these are being added. We can condense it into making it multiplication. So you can do these problems either way. Just depends on where you are in the problem and what type of problem you're doing, which one makes the most sense. Alright, that is all I have for today for 3.3, and then tomorrow we'll do a little bit more of expanding logarithm expressions and condensing them. So we want to make sure that we know these 3 rules really well, so when it comes to that expanding and condensing, we're going to throw all of these together in problems and being able to decipher what needs to be done.